In the city of Oddington, a character named Oddly lived. He loved to dance, skip, and play games all by himself. He had a unique way of standing out and adding a dash of surprise to everything he did. Evan, on the other hand, lived in the city Evanborough. He believed in the power of pairs. He loved companionship. Whenever he appeared, he would bring a friend along. Hello kids, hope you are doing well and welcome back to my channel. In this video, we are going to classify numbers as either even or odd. So first things first, what exactly are even and odd numbers? Let's start with a simple definition. A number n is even if it can be expressed as n equals 2k, where k is any integer. But what does this mean in simple terms? Let's find out with a delicious example. Now here we have got some donuts to help us understand the concept. Let's take the number 4 and see if it fits our formula for an even number. We take these 4 donuts and divide them into groups of 2. So let's do it. One group of 2. And this is another group of 2. So here we formed 2 complete groups of 2 donuts each without any leftovers. This matches our formula where n is equal to 4 and k is 2 because 4 equals 2 times 2. So in our formula, n equals 2k. When we substitute n with 4, it becomes 2 times 2. Hence, 4 is an even number. This practical demonstration with donuts not only makes our math lesson more fun, but it also shows how the formula n equals 2k perfectly applies in real-world scenarios. Let's move on to another example, and this time with number 6. We'll use 6 rockets for this demonstration. Our task is to arrange these rockets into groups of 2. One group of 2. This is the second group of 2. And this is the third group of 2. As you can see, we were able to form 3 distinct groups, and each group contained exactly 2 rockets. So what does this tell you about the number 6? This arrangement visually illustrates that 6 is an even number. But how does this relate to our mathematical formula for even numbers? Remember, n is equal to 2k, where k is any integer. Let's connect this formula to our rocket demonstration. In our example, n is equal to 6 because 6 is the total number of rockets used. K is 3 because we were able to form 3 distinct groups of rockets. So 6 equals 2 times 3, and therefore 6 is an even number. Let's explore another example using the number 10. We can see that there are 10 sunflowers, and the first step is to arrange them in pairs. One group, the second group, third, fourth, and the fifth group. So now we can see that there are 5 distinct groups of sunflowers, and each group contains 2 sunflowers without any leftovers. So the next step is to connect the mathematical formula, which is n is equal to 2k, to this demonstration. N equals 10 here because there are 10 sunflowers, and k is equal to 5 because there are 5 distinct groups. Hence, so substituting n is equal to 10 and k is equal to 5, we have got 10 equals 2 times 5. Hence, 10 is an even number. So, through these hands-on examples, we have just proven the formula for even numbers. whenever you can pair up items with none left over and this pairing matches the formula n is equal to 2k, you have an even number. We have just delved into the realm of even numbers. Now let's shift our focus to the odd numbers. An odd number, being one more than an even number, is very easy to define. An integer n is odd if it is equal to 2k plus 1 for some integer k. To demonstrate what makes a number odd, let's take a practical example with 5 pencils. Our goal here is to group these pencils in pairs of 2. So let's do it. This is a 1 pair. This is another group of 2 pencils. So what did we notice here? We notice that after forming 2 complete groups of 2 pencils, we are left with 1 pencil that cannot be paired. This is the defining characteristic of an odd number. You see, we can evenly divide these 5 pencils into groups of 2 without one being left over. This is exactly what makes a number odd. But how does this connect to our mathematical formula for odd numbers? Remember, this is the formula n is equal to 2k plus 1, where k is any integer. Let's apply this formula to our practical example. In this case, n is equal to 5 because we have the total number of pencils we have got is 5. Since there are 2 distinct groups containing 2 pencils each, k is equal to 2. And so 5 equals, substituting n is equal to 5, we have got 2 times k is 2 plus 1. And here we have got 5 is equal to 2 into 2 is 4 plus 1. And here we see that left hand side is equal to right hand side. And so this confirms that 5 is indeed an odd number. Through this simple demonstration, we have visually and mathematically verified that 5 is indeed an odd number. For our next example, we'll use 9 butterflies to prove that 9 is an odd number. The first step is to group these butterflies in pairs. So we have here one group of butterfly. Let's group these together. And we have another group here. And we can group these. And we formed 4 complete pairs. However, there's one butterfly without a pair. So sad. This lone butterfly indicates that 9 is an odd number. Now let's connect the mathematical formula for an odd number to this simple demonstration. N is equal to 2k plus 1. N equals 9 because there are total number of butterflies we have got is 9. And k. Now we have formed 4 complete pairs of butterflies. So k is equal to 4. And substituting these values into the formula, we will get 9 equals 2 times 4 plus 1. 9 equals 2 into 4 is 8 plus 1. And what does this indicate? This indicates that 9 is an odd number. Now here is a quick puzzle for you. If you had an even number and an odd number, what will the sum be? Think about it and let us know your answer. That's all for today, folks, and may God bless you.